Hello my dear students. In the last video we discussed that the calculation of oxidation number of different compounds. In this video we are going to discuss the what is oxidation, what is reduction, how can we define the oxidation reaction and reduction reaction. Students, oxidation means oxidation and reduction, oxidation and reduction reaction, oxidation and reduction. So before going to discuss the oxidation and reduction, let us understand the one example. Okay, with the help of one example we can understand the what is oxidation and what is reduction. Let us consider a reactant A is converted to B. The reactant A lose one electron, that is converted to B. Here A is loses electron, whereas B can accept the electron, right? That means A loss of electron, A is loss of electron, B is gain of electron, right? A is a reactant, B is a product. A loses one electron and B gains that electron. Here loss of electron based on number of electrons, loss of electron is oxidation. Loss of electron is oxidation. Simply loss of electron is oxidation, Leo. Next, gain of electron, gain of E minus means electron. Gain of electron is a reduction. Geo. Gain of electron is reduction. Loss of electron is oxidation. We can also represent as a Leo is a lion. Leo makes this sound. Gain of electron, right? Gain of electron. Leo or lion makes the sound. Gain of electron is reduction. R stands for reduction. Okay, we can also represent loss of electron, Leo, gain of electron, Geo, or the Leo or lion makes the sound, G-E-R, right? To understand the oxidation and reduction, take one more example, that is a tug of war game. Okay, in tug of war game there are two teams, right? Two teams having the rope, they are holding a rope, right? The two teams holding a rope, right? This is a rope. Let us consider the two teams, team A, team B. Here the rope, here the transfer of electron. Rope considered as a rope. Transfer of electron, transfer or change, transfer of electron. Rope is considered as a transfer of electron. Here A is a one team and B is another team. The team A tries to lose the electron. That means it is a weak team. When the team A loses electron, team B gains electron. Team A weak, that means loss of electron. Whereas team B is a strong team. How can we say strong team? It gains electron. That means the team B pull the rope on team B side, whereas team A loses it is a weak team, hence it loses. That means strong team, B is a strong team, gain of electron. That means one team loses and one team gains. In the chemical sense, in this tug of war game, always the winning team is strong team. Here the B is a strong team. Okay, that means reduction. Gain of electron is a reduction. Winning team. Winning team is B, that is a reduction reaction. Reduction reaction. Here A, the weak team, loss of electron. Here the B is a gain of electron. That means reduction reaction, gain of electron. Loss of electron is oxidation. This is oxidation. Okay. Right. In this method, we can understand the oxidation and reduction. Right? What is oxidation? Loss of electron is oxidation. What is reduction? Gain of electron is reduction. Okay, students. Now let us discuss the oxidation and reduction can be defined in different ways. Okay, oxidation and reduction can be defined in different ways. Let us see. Okay, next. Let us see oxidation reaction. Oxidation reaction. Oxidation. Here reduction reaction. Simply remember, in lower standard classes we discussed that the oxidation means addition of oxygen is called oxidation, or removal of hydrogen is called oxidation. Now reduction is addition of hydrogen is a reduction, or removal of oxygen atom is a reduction reaction. In lower classes we discussed that the based on oxygen and hydrogen. Here based on oxygen and hydrogen, based on oxygen hydrogen atoms, simply addition of oxygen atoms. Here reduction means addition of hydrogen atoms. Otherwise, here removal of hydrogen atoms. Here removal of oxygen atoms. Removal of oxygen atoms. Let us see. Addition of oxygen atoms. That means, for example, S plus O2 gives rise to SO2. Here oxygen molecule, in oxygen molecule 2 oxygen atoms are present. Addition of oxygen atom is oxidation reaction. Now addition of hydrogen, for example, H2 plus Cl2 gives rise to HCl or 2HCl. To this chlorine add H2 atoms. That means hydrogen molecule, H2 molecule are 2 hydrogen atoms. Okay, right. Next, removal of hydrogen atom. See H2S. This one reacting with Cl2 gives rise to HCl plus S. See here with sulfur 2 hydrogen atoms are present, but here only sulfur. This is oxidation reaction. That means H2S. Removal of hydrogen. Hydrogen atoms are removed from H2S, hydrogen sulfide. Here removal of oxygen atoms. CuO plus H2. Cu plus H2O. See, oxygen is removed from the copper oxide. Oxygen is removed. Removal of oxygen atoms is known as reduction reaction. Okay. Next, second one is important one. Based on number of electrons. Based on number of electrons. Based on number of electrons in a species. For example, see, loss of electron. Loss of electron. Loss of electron is a oxidation. Here gain of electron. gain of electron is reduction, right? Gain of electron. Here loss of electron means loss of electron. Can I represent it Leo? Leo. Loss of electron is oxidation. Here gain of electrons, Geo. Leo, Geo, right? See, loss of electron means, example is sodium. It loses one electron, Na plus 1 electron. Here gain of electron, Cu plus 2 ion is present. It takes 2 electrons and converted as a Cu. Right? Is it clear? Loss of electron is known as oxidation. Gain of electron is a reduction reaction. Next, based on oxidation number. Based on oxidation number. Based on oxidation number. My dear students, in the last class we discussed that the calculation of oxidation number of different compounds. Here, if the oxidation number is increases from reactant to the product, that is oxidation reaction. If the oxidation number is decreases, that is reduction reaction. Okay, based on oxidation number. If oxidation number increases or oxidation state or oxidation number is increased, that is oxidation reaction. Here oxidation number decreased from reactant to product, oxidation number is decreased, that is reduction reaction. Here oxidation number or oxidation state increases, that is oxidation reaction. Let us see example. Carbon plus O2 gives rise to CO2, carbon dioxide, right? Here what is the oxidation number of carbon? Can you guess the answer? Already we discussed in the previous class. Elementary form, free state of atom, the oxidation number always 0. Here oxidation number is 0, right? Here what is the oxidation number of carbon? Here in CO2, here the minus 4, this one is plus 4. X minus 2 into x plus 2 into minus 2 equal to 0, then x equals to plus 4. Here 0 to 4. 0 to 4 means oxidation reaction, 0 to plus 4. Increase in oxidation number. Now come to this one. Here oxidation number is decreased. Decrease in oxidation number is, that is reduction reaction. See, CuO plus H2 gives rise to Cu plus H2O. In this, copper oxidation number plus 2. And it is minus 2, then when the sum of the oxidation number of all atoms should be equal to 0. Here oxygen is minus 2, then copper oxidation number is plus 2. Minus 2 plus 2 equals to 0. Next, here copper oxidation number. Here it is elementary form, free state, that is oxidation number is 0. Here plus 2 to 0. Oxidation number plus 2 to 0 means decreases. Oxidation number plus 2 to 0. Here reduction reaction. Okay, that means plus 2 to 0. Plus 2 to 0. Simply increase in oxidation number, oxidation. Decrease in oxidation number, reduction. Okay. And the next one is based on valency. Based on valency. Increase in valency. Increase in valency, that is oxidation. Here decrease in valency. Decrease in valency, that is reduction reaction. Take one example. Here FeCl3, FeCl2, ferrous chloride to ferric chloride. In ferrous chloride, Fe is surrounded with the 2 chlorine atoms, or Fe bonded with 2 chlorine atoms, hence valence is 2. Here Fe valence is 3 because 3 chlorine atoms are attached. 3 chlorine atoms are bonded with Fe. Here valency of Fe is 2. Here valency is 3. Here valency is 3. Now decrease in valency. KMnO4 to MnO2. Here valency is KMnO4, potassium permanganate, manganese dioxide. Here valency is 7. Valency 7. Here valency 4. That means it's surrounded with the 2 oxygen atoms but making bonds with 4 bonds. Right? Each oxygen make double bond. MnO2 valency is 4. Here MnO4 manganese valency of Mn. Valency of Mn is 7. Here valency is 4. Otherwise you can represent like this one also. FeCl3 to FeCl2. Here valency 3, valency 2. Decrease in valence. By this way we can define the oxidation reaction and reduction reaction. Okay. Based on oxygen and hydrogen atoms, addition of oxygen atom or removal of hydrogen atom. Here addition of hydrogen atom is a reduction or removal of oxygen atom is a reduction. Based on number of electrons, loss of electron is oxidation, gain of electron is a reduction. Based on oxidation number, increase in oxidation number is oxidation, decrease in oxidation number is reduction. Based on valency, increase in valency is oxidation, decrease in valency is a reduction reaction. Okay students, next. Now let us discuss the redox reaction. What is meant by redox reaction? Let us see. Redox reaction. In a chemical reaction, both oxidation as well as reduction reaction takes place. Such reaction is called redox reaction. Right? In a chemical reaction, both oxidation and reduction, reactions takes place. Such reaction is called a redox reaction. Let us see Zn plus Cu plus 2 ion gives rise to Zn plus 2 plus Cu. Otherwise, this reaction can represent Zn with copper sulfate solution gives rise to ZnSO4 plus Cu. Right? See here Zn. What is the oxidation number of Zn? It is the elementary form. That means oxidation number is 0. Zn to Zn plus 2. Observe here. Zn to Zn plus 2. 0 to plus 2. That means oxidation. Alright. Now observe here Cu plus 2 to Cu. Here Cu plus 2. Oxidation number is, it is a charged species. Right? When charged species, the oxidation number is charge present on it. Here plus 2 to, here the elementary form, that means free state, Cu is 0. Plus 2 to 0 oxidation number. That means reduction reaction. It is a reduction. Right? Here can represent Zn to ZnSO4 and CuSO4 to Cu. We will find the oxidation number Zn here 0. In ZnSO4, here sulfate ion, sulfate minus 2. To neutralize sulfate ion, minus 2 ion, plus 2 charge. Here copper sulfate, it is minus 2. Total sulfate ion, to neutralize plus 2. Here 0. See, plus 2 to 0, plus 2 to 0. 0 to plus 2, 0 to plus 2. Both are same reaction. When zinc metal react with the copper sulfate, or zinc electrode dipped in a copper sulfate solution, we get the zinc sulfate and copper. Right? So these kind of reactions are called as redox reaction. Right? In this reaction, both oxidation as well as reduction takes place. Here, the Zn to Zn plus 2 is called oxidation half reaction. That is half portion, half part. Oxidation half reaction. Cu plus 2 to Cu, conversion of Cu plus 2 to Cu, it is a reduction half reaction. This is oxidation half reaction. This is reduction half reaction. Okay. Oxidation half reaction and reduction half reaction. Conversion of Zn to Zn plus 2. Zn to Zn plus 2 is a oxidation half reaction. Oxidation half reaction. Okay. Oxidation half reaction. Next, Cu plus 2 to Cu. This is a reduction half reaction. Reduction half reaction. Right? Oxidation half reaction and reduction half reaction. So this is about the redox reaction. Okay. Right. To balance a chemical equation by ion electron method, first of all we have to classify the equation into oxidation half reaction and reduction half reaction based on calculation of oxidation number. So that is the reason why calculation of oxidation number is very, very important one. In the previous class, we discussed the calculation of the oxidation number, right? First of all, write the skeleton equation. To balance a chemical equation by ion electron method, first of all, classify the element, classify the chemical equation in oxidation of reaction and reduction of reaction by finding the oxidation number. How can we find the oxidation number? If the oxidation number is increases, that is oxidation of reaction. How can we classify oxidation of reaction and reduction of reaction? Means if the oxidation number is changes, that means increase, that is oxidation of reaction. If it is decrease, that is reduction of reaction. Right? First of all, write the skeleton equation and identify the oxidation number increase or decrease. If it increases, oxidation of reaction. If it decreases, reduction of reaction. Then one by one, we can follow the different steps. We can finally balance the chemical equation by ion electron method. Right? In the next video, we discuss that how can we balance the chemical equation by ion electron method. Okay. Thank you very much.